Welcome to today's presentation, Automating Cloud Compliance with AWS OpsWorks for Chef Automate. Let's go ahead and get started. Nick, why don't you kick us off by telling our audience what we'll be covering here today?
Thanks, Jamie. So outlined here, we have a quick agenda of the webinar today. We just got through introductions and housekeeping, and from there, we'll dive into a bit of an overview on the concepts of continuous automation and cross-team collaboration with Chef. Then Jonathan's going to run us through OpsWorks for Chef Automate, the details of the service itself, as well as a live demo of launching a new instance into your AWS account. We'll then head back to me, where I'll outline some of the processes to achieve continuous automation, a workflow of detect, correct, and automate, before diving back into a live demo so we can see some audit and configuration of existing servers that are unmanaged in our environments. Finally, we'll talk a little bit about some of the extra features of using OpsWorks for Chef Automate, and in particular, being able to set up automatic Chef node association using the OpsWorks Configuration Management API. With that, we'll demo creating a new auto-scaling group and make sure that our systems are configured and audited before we wrap up the webinar and dive into your questions. But before we get started, a quick poll to start things off. How familiar are you with AWS, Chef, and OpsWorks? Should be selections for every combination of familiarity, from I don't know any of them to I'm a pro on all of them and want to learn more. So we'll give you a minute or two to submit your responses there, and then we'll move on. All righty, let's see. So we got a pretty good breakdown. Looks like just about 80% of folks are familiar with at least AWS. Looks like the large majority of folks are going to be new to OpsWorks, even if they are old hats with AWS and Chef. And a few folks that may have caught our last webinar are using OpsWorks today and just want to see an overview of its features. So that's great. And with that, we'll dive in a little bit to framing what problems that we all try to solve as IT professionals that are in charge of servers, environments, websites, applications, the whole nine. Ultimately, what makes us able to outpace our competition is by being able to deliver increased speed, increased efficiency, and reduced risk in our environments. It's important, however, not to address any of these individually, as improving one metric can have an corresponding degradation in another. So it's important that as we automate our systems, we make sure that we're keeping in mind improving our speed and efficiency without increasing our risk alongside them. One way to achieve this is to practice continuous automation, a way to ensure that everything that you need to validate or configure is automatable and repeatable. We call this cycle, in short, detect, correct, automate. If we have the means to detect any issues in our environment, correct those issues wherever they appear, and automate the process of doing both, we can move on to solving net new issues without having to resolve issues that have hit us in the past. With Chef's toolkit, we'll be using Inspect to detect our issues, Chef to correct them, and since both of those tools are built from the ground up for automation, once we've got them in place, we're already automating both processes and can move on to our next big things. Now, where Chef Automate comes into play is what happens after we start configuring and auditing these systems, but require both the ability to scale out that process and maintain insights into how things are configured, but also collaborate across teams. Where can my DevOps professionals, my security and compliance professionals all go to have a shared worldview of what is true about our environments? Chef Automate aims to provide just that, where we can see the details of every configuration step, as well as every audit that has been executed across our environments, across our data centers, all in one dashboard that can be filtered with a complete historical view so we can see where things have changed in the past as well. And with that, I'm going to hand things over to Jonathan to give us an overview of OpsWorks for Chef Automate.
Yeah, so also welcome from my side. So I want to talk a little bit about OpsWorks for Chef Automate, which is our joint offering between AWS and Chef, where we make it easier for you to actually run and operate a Chef Automate server, right? So in order to do all the wonderful, interesting things that we're going to look at today during the webinar, we need to have our own Chef Automate server. And that needs to be installed, it needs to be configured, it needs to be operated securely long-term, right? We need backups, we need to be able to restore it, we need to install any updates on security updates and so forth over time. And this is exactly what the OpsWorks service is helping you with. So with AWS OpsWorks for Chef Automate, you get your own Chef Automate server where AWS is taking care of all of the things that I just mentioned. So you select the region and the server type you want to have, and then AWS takes care of the installation, the configuration, the monitoring of the machine, the backup handling, any restore operations that you like, and then we auto-upgrade any new version updates and also any OS patching that is necessary. So pretty much we take care of all the heavy lifting that is necessary to run a Chef Automate server in production, and that makes it possible for you to just focus on actually using Chef Automate and all the tools that we will learn about today, like inspec, compliance, and then obviously Chef itself to do any configuration changes. Now, the offering itself is fully compliant with the Chef ecosystem, right? Like you get truly just a Chef Automate server that has a lot of tooling around it done by AWS. So you can use the Chef supermarket with it. You can use the DevSec hardening cookbooks and profiles with it. So it is fully compatible with other tools like Test Kitchen and Knife and so forth, of course. And then on the other hand, because this is an AWS service, we can integrate very nicely with other AWS offerings like EC2 autoscaling, CloudFormation, CloudTrail, and other services that we will look at actually later on. In particular, autoscaling, we make it a lot easier for you to register newly launched nodes into or with the Chef Automate server so that you don't have to set up this trust relationship yourself. We will actually demo that later on. So you can benefit from this deep integration between, on the one hand, Chef, and then this being an AWS service, so that you don't have to do a lot of this integration yourself. Now, the demo that I want to give you is about how do you actually get started, how do you create your own Chef server, and how can we leverage this yourself, how can you actually do a quick POC and try it out yourself. So let me share my screen and walk you through that process. So hopefully you should be able to see my screen now. So I'm logged into the AWS Management Console, and here you need to look for OpsWorks, and then in OpsWorks, you can, here we allow you to launch your own Chef server, and this wizard experience is what I want to walk you through. So I select that I want to have my own Chef Automate server, and then there are four hopefully pretty simple steps that we walk you through until you have your own Chef Automate server running. So we can give it a name like my webinar demo server in this case. I select the region the AWS region in which I want to launch my Chef server. I select an instance type, so you can, depending on how many nodes you're planning to register, you can select a larger or a smaller instance for the Chef server. We support also more instance types on the API, but for simplicity reasons, let's pick a smaller one here. And then you can select if you want to be able to log in by SSH to the server. At the end of the day, this is still we automate for you the installation and the configuration of the Chef Automate server and all the backup, restore, handling, and the updates. But at the end of the day, if you really need to, you can have SSH access to the machine. In this case, I'm going to skip that step. And now you need to tell us how do we actually should be configuring this machine in terms of your networking, right? Like, what is the VPC, the virtual private network you want to control this machine in? So in this case, I'm picking an existing VPC. You can also use our documentation, and we have an example CloudFormation script that will create your own VPC that is configured correctly if necessary. You select the subnet within that VPC. You can define if you want to have a public IP address, which is necessary if you want to be able to connect to nodes outside of that VPC, or for correctly configured other VPCs that route with this one. If you run everything on AWS and everything is within VPCs, you don't need that. In this example, I'm going to keep that. You pick a security group that you want to give the server, or you can have us generate a new one. And then there are the necessary IAM roles, where the defaults also is usually what you want, which is what are the permissions that this machine should have in order to talk to all the various services that we need. So that for these parts, you can pretty much leave the defaults. And then maybe the slightly more interesting part is how do you want us to run maintenance and backup? So you can see here, you can define a system maintenance schedule during which we will install all necessary updates. We'll do kind of a blue-green restore for the server with OS updates, Chef version updates, and we'll essentially launch a new server from your last backup that we do right before the maintenance window. Launch this new server, see if everything is running nicely, and if it is, we're flipping you over to this one, and if not, we're rolling that back. So you can define when should this happen, at what particular time, and at the same time you can define the backup schedule. So you can tell us, do you want a regular automated backup? What is the frequency for this backup, like daily or weekly? When should it happen? How many backups do you want to keep? And then we will do all of this for you, so that in case there is ever a problem with the server, you can restore it from the backup. Or if you, a common scenario that we see with our customers also, they often have kind of an example set up for the server where they already have some maybe standard cookbooks installed or certain configuration in there, and then different teams are using this kind of as a blueprint for their own, where they're installing this server from a backup of that blueprint server. So you can also restore new servers from a backup on an existing one. So in this case, maybe I don't want to have daily backups. Let's say weekly is fine with me. You can define what is the day of the week that you want to have your backup taken, what is the time of day, and then how many backups to keep. And then pretty much we're done by now, right? Like I'm just have an overview here of the settings that I selected. If I can check if everything is correct, and then I say, okay, go on and please launch this for me. So what OpsWorks is now doing, it's provisioning this server in the EC2 instance and the necessary resources in your account on your behalf, is configuring them all correctly, is installing the Chef Automate product and on this instance, and is making sure that you have everything you need in order to operate this. And then once the server is up and running, we do obviously the regular backups and maintenance windows that we talked about. We have regular health checks and monitors that we're running, and you can manage the server going forward. Another two things that are very relevant here on this page is on the one hand the credentials, on the other hand the starter kit that we strongly recommend you download, right? So if you download these credentials, they will include, or they will show you what is the admin username and password that is necessary to log into the Chef Automate console, that you can of course later on change on the one hand, and on the other hand the starter kit that will allow you to use Knife, and also will show you the user data that you can use to register additional nodes. You can download that also later on, but for the credentials, this is something that if you don't download it right now, you can reset the password, but that's a slightly more complicated effort. So we recommend you do this when you launch and create the server for the first time. And down here, we have just the summary information of the machine and what are some of the recent events related to this and what are the recent backups. Now, maybe to show you what is included in the starter kit, I've already downloaded for another server just as an example. What you will have in here is all the necessary data for an example setup for an OpsWorks audit cookbook. You can have the necessary configuration to run Knife directly on this machine to connect to the server. And what I have here is the example user data script that Nick will actually use later on to connect an autoscaling group and instances, EC2 instances that we launched with the autoscaling group to the Chef Automate server. You can obviously override and change these, and this is just an example, but if you just copy paste that script when you launch a new EC2 instance, that will automatically register the node, or in this case, the EC2 instance, with your Chef Automate server, and then we'll run the run list that we have in here, where here we just have an example role set up, but obviously you can replace that with anything you like, or with anything you already have pre-configured on the Chef server. You have the same user data example for Windows, as you can see here, and then you have the example cookbooks for this OpsWorks audit cookbook here that you can run. You can easily replace that with everything that you like. This is just more meant as a way to get you started, as a good example of how can I now register my first nodes from here. The important part is the user data and then the credentials that you can use to log in to your Chef Automate server. Now, this process will take a few minutes to finish because we're provisioning all and configuring all of these resources. But hopefully you got the idea how easy it is and how quickly you can have your own Chef Automate server. And the nice thing is that you can obviously only use it as long as you need. You can register the nodes for as long as you need, and really benefit from the dynamic and pay-as-you-go model that we have at AWS. And with that, I would hand over to Nick that will explain to us what can you actually see once this server is successfully launched, and how do we then take it from there in order to register our nodes and run inspect and do all the compliance checks with that. So let me stop my screen share and hand over to Nick.
Thanks, Jonathan. So yeah, what we'll be looking at today is essentially what Jonathan will have on his desktop in about 10 or 15 minutes, which is a freshly launched OpsWorks for Chef Automate instance. I have pre-seeded some nodes, so we have some good data to work off of as we are outlining the way the console works. But then we'll essentially run through exactly what you would be able to go through on day one once you download that starter kit and have your OpsWorks instance ready to run. Now, before we dive in, we have one more poll question here. As mentioned earlier, we're going to start this continuous automation process with detecting issues in our systems. And that can be anything from ensuring that configurations have been properly applied to doing formal security and compliance audits. And on that latter front, I'd like to ask everyone here how often you currently audit the security of your systems, either via homegrown standards, making sure vulnerabilities aren't present and systems are patched, or to comply with regulatory agencies, your PCI, HIPAA, FedRAMP, and GDPRs of the world. All right, let's see how we did. So it looks like everybody's doing some kind of auditing right now, and it's a pretty even split. It looks like about half of folks are doing those audits monthly to weekly, 20% yearly to quarterly, 20% at least daily, and 10% doing it daily or better in all of their environments. And that last part is really the part I'm leading us to here, which is that traditionally, we're really only evaluating security infrequently and in production alone. A trend that has come across in the industry is shifting this security and compliance consideration left, where we can start applying those same validations to our testing and development environments so that we are able to catch issues early and not potentially endanger a release or, God forbid, push something insecure to our production environments. So with that, we're going to take a look in this first part of the demo at the first two steps of that continuous automation cycle, detect and correct. When we talk about detecting with inspect, what inspect provides us with is a easy to learn language for defining expectations in our environment. what should be running, what shouldn't be running, and what frameworks do I need to comply with. When you run OpsWorks for Chef Automate, you also have a library of pre-written profiles available for you in a profile store so that you don't need to write any code and just download one that exists, run it against an existing system, and these can be done over SSH or WinRM, so no agents need to be pre-installed to accommodate this, and we can start getting some feedback right away as to where there are security vulnerabilities or misconfigurations in our systems and can start planning our remediations accordingly. Speaking of, when it comes time to apply those remediations, Chef is a tool that, like Inspect, provides a language, this time for determining what should be installed and running in our systems and how they should be configured. Chef is designed to be repeatable by default so that when you reapply Chef to an already configured node, it will only change things that have deviated from their desired state. We get the benefits of automated drift correction, but also it's safe to run on properly configured systems where Chef will just detect that things are configured properly and take the appropriate action. And with that, I'm going to go ahead and share out my screen here. So in a moment, you should start seeing my OpsWorks dashboard. So this is effectively what things look like after the launch is complete. We can see things like the health of our system. We have the ability to regenerate a starter kit if we don't have access to the one that was created at launch. And we can also go in and adjust our settings if we want to change our backup or upgrade schedule after launch. As for the Automate server itself, here it is. So as mentioned, we already have some things happening here. I've got 6 nodes that I'm already managing, and those nodes are all passing their audits. You can even see here which profiles were used to evaluate these systems. I have a security baseline and an SSH baseline that were grabbed from this profile store. So here we can see the full library of pre-written profiles that are available to you as soon as you launch OpsWorks for Chef Automate. To inspect what any individual one is doing, we can go in and evaluate the rules that are being evaluated one by one, even going so far as into their source code. But we can also just hit a Get button to install a new profile into our available profiles. So in addition to the 2 I had previously, now I have installed, refresh my screen, CIS benchmarks for AIX 5.3 and 6.1. I don't have any AIX servers to evaluate today, but if I do, I now have a means to do it. What I do have to evaluate today are 3 servers that have been created, but are not currently being managed by any automated audits or configuration management. And so to take a look at how we would go about starting to audit and correct those machines, we would start by creating our credential. Now, I've already done this because I am logging in via an SSH key, and I don't exactly want to share my private key on a live webinar. But to see what it looks like, we have the ability here to create a name for a credential for SSH, WinRM, or if we need to supply a password for sudo, we can do that as well. And we can provide either a password or an SSH key when defining that credential. In this case, we already have that done. So we're going to head into the scanner and first start adding nodes to scan. We can do that by clicking the Add Nodes button here, and then just giving it a comma delineated list of IP addresses or host names for the machines we want to connect to. Right now, I have 3 Ubuntu machines named creatively enough, Ubuntu 1, Ubuntu 2, and Ubuntu 3. I'm going to go ahead and create those on my Automate server. We need to tell it how we're going to connect. Since these machines are running Ubuntu, I'll be connecting over SSH, and I'll be using the SSH credential I supplied earlier. Once that's done, I simply just click Add 3 nodes. We see here a node I added earlier for testing, but as we add these 3 nodes, Chef Automate is going to ensure that it's able to reach those systems, and indeed, all of them are reachable, and we even get a little bit of abbreviated profiling information. They're running Ubuntu 14.04. Now, if I want to start scanning those machines, instead of adding new nodes, I'm going to create a new scan job. We'll call this one Ubuntu Security. Now, we can optionally set a schedule here if we wanted these scans to recur and can define the cadence at which that happens. But if we leave this set schedule box unchecked, it's simply going to run a one-time scan against whatever nodes I select, this time Ubuntu 1, 2, and 3, using whatever profiles I select. I'm going to use the Linux Security Baseline, which is a collection of best practices security standards from a variety of sources. As we see, just like before, we start with a scheduled scan that is now running. And when the scan is complete, I'll be able to evaluate how my pre-existing machines are configured and whether or not they pass security muster. We see now Ubuntu Security has completed scanning 3 nodes, and I can go to the report where I see, 3 nodes, 3 critically failing scans. Within this dashboard, I can investigate the details of that, either broken out by node or by the profiles executed against those nodes. Here I see my 3 nodes are all failing that scan, and I can go in to see the full details of what happened, which controls passed. It looks like 76 considerations were in their proper state. But if we look at critical controls here, I do have a few problems that need to be solved. For any of these, we can go ahead and take a look at the details. And we see here that each of these controls can actually contain multiple tests. Here in our check login defs control, we can see that some aspects of it are passing. The file exists, it is owned by the right user, et cetera, but we see that it doesn't have a UMask setting that complies with our standards, password max days, oh, that's not a great value, and so forth. As mentioned before, we can even take a look at the source code to see how inspect rules are structured. As we mentioned earlier, this is helping us build a collaborative tool. If I'm a manager, a compliance officer, or maybe even a security person, I might not care all the way down to the source code, but I do want to know which things are passing and which things are failing. But if I need to go in and I'm now a developer or an operator that has to go and fix this problem, I want to know exactly how inspect was validating it so that I can implement the proper fix. Now, if you've joined us on our previous OpsWorks webinar, I took care of correcting issues using a tool called Knife to bootstrap machines for regular Chef client runs. That said, one of the new things that we announced at ChefConf this past May is a tool called Chef Workstation, which includes the Chef DK, our development kit, but also includes a new tool called Chef Run that allows us to run Chef against remote targets directly over SSH or WinRM without needing to bootstrap them formally, allowing us to start applying configuration changes quicker than ever before. So now that we've identified these problems, I need to go about fixing those problems. And indeed, I have a directory already populated with some stuff. So if we take a look at the directory I'm in now, this is actually that starter kit directory that Jonathan brought up earlier. The biggest difference here is that I have downloaded some cookbooks from the Chef Supermarket. So if we take a look at my cookbooks directory, you'll see, I probably should have did an LS there. Let's try that. Oh, too much data for us. I have a few auditing and hardening cookbooks in here that I can start making use of. What Chef Run allows us to do is to take any locally installed cookbooks I have or cookbooks that exist on a Chef server, and I can run the Chef Run command against whichever servers I'd like to scan. So here I'm going to be logging in as the Ubuntu user at my Ubuntu. And here's the cool part. I don't need to define them individually. Since my naming convention is just a series from 1 to 3, I can actually run this in parallel and use this shorthand to make sure I'm scanning all of my servers. We'll define what recipe we want to run on these machines. So I'm going to take that DTA Hardening Linux cookbook, and I'm going to run its default recipes to apply a hardened configuration to these 3 systems. Then all I need to do is tell it which SSH key I want to use. So I'm going to use my Rycar PEM file here. And we're off to the races. So what happens here is that it will create an artifact called a policy file, which essentially just contains all of the configuration policy we want to apply to our target nodes. And make sure that Chef Client is available on our targets if it's not already. So here, we didn't have Chef Client already installed, so it's making sure that we have it. And then it will run Chef Client to converge our targets and send the data back to Chef Automate, where we can view whether or not we successfully converged our machines. So you see here, it looks like all three are now running their Chef Client recipe. We've got 1 successful converge, 2, and 3. So the process for using Chef Run is as simple as that, but the proof is in the pudding. I'm going to hop into the nodes view here, and we'll see that where I had 6 nodes before, now I have 9. You see all the nodes that I created previously, as well as my new nodes. Of course, right now they're all using their default Amazon host names. I could go ahead and sort by when they last checked in to see the 3 machines that I just configured. Another thing that is worth calling out, since we didn't bootstrap these nodes against our Chef server, like the nodes that I had previously sitting here, we can actually filter between which machines are in my default organization. These are the ones that have been launched into my auto-scaling group and bootstrapped with Chef. But we can also see which ones were configured with Chef Workstation, which includes a test node that I ran this whole process on an hour ago to make sure everything was looking good, and the 3 nodes we just created. If we want to close the loop, however, well, remember, I didn't choose to set up a recurring scan, so we can just get some immediate feedback. So I'm just going to create a new job, just like we did before. See whether applying that hardening cookbook actually solved the problems that brought us here. We'll call this Ubuntu Post Configuration Management. And we'll do another one-time scan so we don't have to wait for the interval and we get some immediate results. And with that, we'll just go ahead and create another job. Just like before, we'll go from scheduled to running to completed, and we'll be able to see whether or not we've actually solved the issues that brought us here. Okie dokie. Looks like PostCM has run, and PostCM comes back clean. So now we've validated that our issues have been solved and can move on to our next tasks for whatever we need to automate next. It's worth noting, even though I created 2 separate scan jobs here, when we go into the aggregated compliance view, it does notice that we ran them against the same 3 nodes we had run against previously. So it does show us a up-to-date world view where we'll also be able to see the full scan history for each individual server. So if I did want to reference when scans were failing and what the nature of those failures were, I still have access to that data in this console. With that, I'm going to stop my screen share for a moment, hop back into the deck, and before we dive into the last piece, let's go a quick review of how we've done our detections and corrections today. So we have both created a scan job in this case, so we can audit that system directly over SSH and get real-time feedback. We used Chef Run to apply our configuration corrections via Chef. And now, before we move on to our next thing, we need to make sure that that process has been effectively automated. I'm happy with the servers I've configured already, but what happens when I need to launch something new tomorrow? How do I roll all of that stuff I just did into a single process going forward so I don't have to reapply these steps every time I start deploying something new? Before we take a look at that, one last poll question for the group today. So how are new instances provisioned in your environment? And we kept this pretty broad since there's a whole lot of answers to that question and contained it to, are we manually launching those instances, say via the EC2 console? Are we manually configuring those instances either via SSH scripts or just logging onto the box and updating them? Or have we automated either of those processes, as with tools like auto-scaling in AWS or with Chef for configuration management? Or are we doing both? And spoiler alert, today we are going to do both. So let's see. Okay. So this is some interesting feedback from my mind. So it looks like we've got a lot of automation going on in the crew already. That's fantastic. But the thing that strikes me here is that if we're automatically launching things, well, we're automatically configuring them. It looks like there's nobody that is just doing a one-time configuration with their automatic launch. So that's fantastic. Now, when we take a look at what tools we have at our disposal to do this in OpsWorks for Chef Automate, it's worth understanding a little bit about how Chef node association works. So what we saw previously was me pushing out a change via Chef run to a endpoint. The issue with doing that for managing systems long-term is that we need to go and push out that change every time we want to validate or update those configurations. Instead, Chef allows us to create an agent-based pull model where Chef client runs on a regular interval, establishes trust with a Chef server via a access key, and then applies that configuration locally and sends the results back to Chef. For OpsWorks users, there's actually some built-in functions in the OpsWorks CM API so that we can validate our IAM roles, make sure we have permission to add new Chef clients to our environment, and then take care of that whole bootstrap process unattended, which allows us to make use of tools like auto-scaling without needing to figure out how to run through user-attended bootstrap processes, similar to what I did on our last webinar with Knife. So to that end, I'm going to share my screen once again, and we're going to take a look at just how to handle this configuration. So it's worth noting that I have taken care of some steps ahead of time for both testing my environment and for brevity. But everything that I've done is in this adding nodes automatically document within the AWS OpsWorks doc. This includes creating the aforementioned IAM profile that allows us to associate nodes with our OpsWorks instance, as well as creating and associating user data with our launch configuration that tells it how it should be set up at boot, including making sure that the AWS CLI and Chef client are installed, and defining the initial run list, which is going to run, spoiler alert, the same detection and correction policies we ran directly against our Ubuntu 1 through 3. To get that up and running, we're going to hop into my EC2 console here, and I am going to go into auto scaling. So first up, a quick nod to the launch configuration that I've already created. So this OpsWorks webinar main is where I have defined that IAM profile and the user data that we'll be using to launch things. So at this point, all I need to do is create a new auto scaling group. We have one that I created before. That's where those first 5 instances came from. So I'm just going to go ahead and create a new one. We're going to use the same launch configuration because I want it to essentially look identical. And let's just make it another 5 instances. Keep it at a nice round 10 that we have in auto scaling. We'll call this one OpsWorks Live Demo. We'll keep it on the default network, and I'll just use the default subnet. And from there, all we need to do is define our scaling policies. Now, for your production environments, we probably will want to actually create a policy, say if CPU utilization or network traffic gets high, I want you to automatically create or remove nodes. For the purposes of this demo, though, I'm just going to keep it at a static size. We'll keep those initial 5. I would probably also set up some notifications and tags in my production environments. But that's the beauty of doing demos, is that I can be a little bit of a cowboy. So right now, we've gone ahead and started up our auto scaling group. It's going to start creating servers for us. But as soon as those servers are created, we're going to start getting data back into Chef Automate here. So while we're waiting on that to happen, and let me remove my filter so I don't panic and think that I only have 4 machines. There we go. I'm going to hop into the screen, or hop out of the screen share for a second for a quick summary of what we just saw, and then we'll poke our heads back in and see how how things went. Ah, yes, the slide that I meant to show you before I went into that demo, but it's a great summary of what we just did. So we use that user data file to configure the unattended bootstrap of our systems, associating with them with the Chef server in our OpsWorks instance, and then configuring it with, in this case, a Chef role that defines both the configuration tasks we want to take, in this case, running our hardening cookbook, as well as defining our audit behavior. While we saw that SSH-based audit previously, anything that is managed by Chef can also automatically trigger audits during its Chef client run via a publicly available cookbook called the Audit Cookbook, which is what we're using here. Again, that same role specifies the correction steps, in this case, that hardening recipe that we ran previously. And ultimately, what we end up with is some validation of those success metrics that brought us here. I mentioned at the top that it's important that we improve all of these in tandem. And so we'll take a look at what our activity today has actually done to measurably increase our speed efficiency and reduce our risk. So now as far as speed goes, well, we have real quick ways to audit and configure systems regardless of how they've been created. They've already been launched. We have facilities to do those audits and corrections over SSH and WinRM. And if we're bootstrapping them or adding them to an auto-scaling group, we can have those processes handled automatically. Of course, that in turn increases our efficiency. We're no longer manually creating things when we are throwing those configurations into services like AWS auto-scaling, and we don't have to manually account for validating or configuring our systems. We have the process automated and repeatable so that we always know our systems are configured properly and compliantly, securely. We'll see what adjective I want to use there in future. At any rate, that does tie into the last metric, which is risk. We're now running audits anytime we make a configuration change so that no matter what I do in future to change how my servers look, we'll always know whether or not that change impacted my security and can take action if it did. So I'm going to start the screen share back up and we'll see whether or not my auto-scaling group did what I expected it to, and just refresh my window here. But hey, while we were covering those slides, it looks like I now have 14 servers. They have successfully converged. I can filter by the check-in that completed 2 minutes ago. As before, we can see exactly what changes Chef made here. And I see that from my stock image, it had to make 80 changes in order to bring it in compliance with my requirements. And is it in compliance with my requirements? Well, yes, it is. So now all 14 nodes I'm managing also have audits associated with them, so that as soon as my cloud or my auto-scaling groups add or remove nodes, we're always making sure we get data about their configuration and can validate that those newly launched instances or ephemerally launched instances are always configured and as secure as I need them to be. And that's about it for the live demo here. So I'm going to hop into some wrap-ups here, and then we'll start taking a look at folks' questions. So indeed, if you'd like to learn more about running OpsWorks for Chef Automate, aws.amazon.com/OpsWorks is where you'll want to go. It is free tier eligible, so you can start trying it out and get familiar with it. And includes an integrated Chef server, so you can store your cookbooks and bootstrap your servers without needing to create anything beyond that initial OpsWorks stack. We also have libraries of resources for you to start learning how to use Inspec and Chef to start handling that detection and correction. At inspec.io, you'll find hands-on tutorials and extensive documentation on Inspec, some pre-existing profiles, and some resources to create profiles of your own. And at devsec.io, you'll actually see both the security profile I used and the hardening cookbook I used, which are publicly available. And then for folks that are running OpsWorks for Chef Automate, there's a library of extended profiles to start doing more formal regulatory compliance with frameworks like CIS or DISA STIG. And with that, since I have been gabbing nonstop, I'll check in with my compatriot Jonathan to see if there's anything he wanted to add before we start diving into your questions.
No, I think you covered everything. Let's look at the questions that people have.
Excellent. So first one, I think I know the answer to this one, but I'm going to defer to you on it. Someone asked whether there's a way to control the size of an OpsWorks instance after it's been created. So could we say launch a small and then take that running instance and turn it into a large?
Yes, there is a way to do that. You do this with the kind of backup restore maintenance window schedule. So we would take a backup of your running server, change the instance size, and then launch you the larger one and restore the backup, which will get you to the same state. So yes, you can do that.
Excellent. So someone asked, and this one looks like one for me, is there a way to override default attributes in cookbooks for Chef Run like environment spiral would do? So at a high level, the answer is yes. I would have to actually take a look and see what the full list of options are there. Typically, the way that I have done that is via wrapper cookbooks, which, again, in this case, kind of a cheat. I'm just using a different cookbook that wraps around the initial cookbook, and I'm resetting the attribute there. And I know that it creates a policy file. What I'd need to check with the team and docs is whether or not you can point it directly at those. You don't necessarily provide it with a traditional run list like a machine that's been bootstrapped, but it's much more similar to using Chef Solo or Chef Zero as far as that goes. So I will at the very least commit now while I'm being recorded for posterity that as we post the summary, I'll expand on that and see what the full options are there. It is worth noting, however, we saw that data come into our OpsWorks for Chef Automate instance, and that's actually something that's configurable within the Chef Workstation config file. All we need to provide it with is two parameters: the URL to the Automate server we want it to send data to, and a authorization token, which can be pulled from the config on the server itself. So I'll be making sure to give details on that as well when we post the summary. So let's see here. Can we alter a chef-managed instance by an external event? So I think I'll go ahead.
Yeah, I'm not 100% sure what is meant here, but maybe let me talk what you can do, and hopefully that answers the question. So the instance of the OpsWorks, if the question is about the OpsWorks instance, then that has a full API like any AWS service. So you can use the API, the SDKs, the CLI to interact with that instance, which means you can also use CloudWatch events and Lambda to trigger these API calls. So you can use CloudWatch events to generate an event or an alarm, to then use Lambda to manipulate the instance, the Chef server instance itself. If you're talking about the actual nodes connected to the Chef server or the Chef Automate server, then you could do similarly by using, for example, CloudWatch events or Lambda again, that then uses like something like Knife, for example, to interact with the Chef server APIs directly. So it depends a little bit what you want to do, but everything that I think that we showed here today has APIs, so you can automate or trigger by events and depending on your needs.
Couldn't have said it better myself. That covers all the bases for me there. Question, is there an ETA for the release of Chef Workstation? Yes, it has been released. So the big thing to be aware of there, if folks are already using Chef DK, there should be a call out in the instructions, but you should still have all of the Chef DK in Workstation. So I guess what I meant to say there is if you're not using the Chef DK already, installing Chef Workstation includes the Chef DK. And the only thing that installing Chef DK by itself does not currently include is that Chef Run utility, which is freshly released as of May at ChefConf. So that can all be found at chef.io, and there'll be some links provided after the webinar to get folks some direct access there. So let's see here. How does the auto population work in Chef Automate when the machines are spun up by Amazon? So in this case, that was controlled by the user data that we created in our launch configuration. And this is actually, if you're using the AWS CLI to launch something directly, there is a flag to allow us to include user data there as well. In either case, the way this user data is doing it requires us to make sure that our instance has the IAM policy described. But that documentation piece that we showed earlier and that we'll be linking in the follow-up has the full rundown on how to create that profile and how to define the user data, which actually comes included in your starter kit when you download it. So you'll have that Windows and Linux user data sitting there alongside your Chef credentials when you download that starter kit. How does... Oh, yeah.
Sorry. A question I've seen is about the Automate licenses and can you use them together with OpsWorks? And the answer is yes. So if you already have a Chef Automate license, we support with OpsWorks for Chef Automate bring your own license. So you can reuse these. You can use the same license for on-prem, or you can talk to us and Chef, and then you can reuse them also on AWS. So that definitely works.
Indeed. Someone had asked as well whether you can integrate on-prem and cloud instances into this. And the short answer is absolutely yes. The fine print there is if we wanted to use the scanner, which makes an outbound connection over SSH or WinRM, our OpsWorks instance would need to be able to have a point of ingress to those servers. So they would need to have a public IP or VPN connection for that to handle outbound. But if we're doing Chef client runs or basically anything we saw in that auto scaling configuration, all that would be required is HTTPS out from the instances you want to manage to the OpsWorks server. They'll essentially reach out to pull down whatever policies are required, and then over the same HTTPS connection to give their results. And just as we were able to filter our view based on which machines I configured with Workstation and which machines I configured with a Chef server, we can also filter the output on a number of other axes, including things like what environment things belong to, as well as even what cloud it's living on, since that is auto-pulled via Chef's system profiling tool, Ojai. Let's see here. This is actually a good one and related to a comment I made earlier about configuring Chef Workstation, which is how do I find the data collector token for my OpsWorks provided Automate server? So if you're using Chef Run like I'm using, or you have done similar client-based connections to Chef Automate, there's a couple of ways to populate the data. If you're bootstrapping against a Chef server, you don't really have to do anything. The Chef server itself gets integrated with Automate in the OpsWorks instance, and anything that you do on the Chef server will show up in the node list. If you're doing a local run like I did, you need what's called a data collector token, which is essentially just a little authentication credential to make sure it can send its data to Automate directly. And that is actually currently found on the Automate server itself. So when you create an OpsWorks for Chef Automate instance, you have the option to define whether or not you want to set SSH key access to it. And when you're SSH'd in, there is a show config command that will include that data collection token. And we've been talking a little bit about ways to make that easier, potentially include it in the starter kit. But for right now, we'll include sort of the instructions for how to replicate that piece of the demo when we post our recap summary. And let's see here. It looks like we're coming near to the top of the hour. So actually, here is a good question. Why would a user use inspec over an AWS provided offering, I assume for similar types of validation?
Yeah, I'm happy to take this one as the AWS parties. From our perspective, I think this is much more a thing of you can use this together and versus use this instead. So inspec is great for like understanding and checking what is going on inside the instance, right? Like you were saying and looking at your examples of what particular configuration do I have on the machine, what packages are installed, what configuration is present, what files exist, what permissions are there, and so forth. And this is great information where a tool like Chef and Inspect that operate on the on-instance level are very, very useful. And then with AWS, we have AWS config that checks kind of on the resource level in AWS in terms of what services do you have provisioned and how they're configured. And you can use all of these tools nicely together where config is very well integrated with other services, and you can use config rules to define like these very similar to inspect these violations of I don't want to have an S3 bucket that is configured world readable, for example, and then with inspect you can run the checks inside the instance. Something that as part of this partnership we're actually are very interested in is how can we integrate those two better and like make sure that the data from both of these sources flows in both directions. This is something that we're actually looking at to how can we improve that for our customers.
Excellent. Thanks, Jonathan. And I think with that, before we close up, I'm going to pass the baton back to Jamie to wrap us up.
Thanks, Nick, and thanks, Jonathan. Awesome demos and great information. For those of you that submitted questions that we didn't have time to answer, we'll follow up with you via email and address those in the next week or so on the Chef blog, where we'll recap everything we covered here today. As a reminder, a copy of today's slide deck and additional help materials are available in the resource list widget at the bottom of your screen. We encourage you to download the slide deck and bookmark any links that you may find useful. We, of course, hope you found value in the information that Nick and Jonathan presented today. If you like what you saw, we encourage you to share the recorded presentation with your teammates or professional networks. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. Thanks again for your time, and have a wonderful day.